this video, we will go over New Relic Alerts streaming aggregation methods, a part of the Applied Intelligence product under Alerts. Alert streaming aggregation methods increases the reliability and accuracy of alerting, significantly reduces time to detect, and decreases customer support escalations. In order to set a streaming aggregation method, you'll need to edit an existing condition or set the aggregation method in a new condition. Begin by logging into New Relic 1 and clicking on Alerts and AI on the top navigation bar. Proceed by clicking on Policies from the left-hand navigation menu under Detect. Here is where you can either edit an existing alert condition you've already created or add a new alert policy and then add a condition. For this example, I will choose an existing condition. Once you create an NRQL condition or choose an existing condition, go to the Fine-Tune Advanced Signal settings. Now I can specify the aggregation method I want to choose. As we can see, there are three streaming methods: Event Flow, Event Timer, and Cadence method. Event Flow is a new streaming aggregation method NRAI has released, which is shown as the default setting. In this streaming aggregation method, the aggregation delay accommodates the timestamp jitter that may be present in the data stream. Event Flow relies on data continuously flowing in to trigger the aggregation and evaluation of your data. If your data stops flowing in for any reason, the system will pause and wait for more data to arrive. If you do set an aggregation delay, the pipeline has to see a data point with a timestamp that is that much later than the end of the aggregation window. To put this into visualization, let's draw out what this might look like through a metaphor. Imagine you had a tube and were stuffing data in that tube constantly. If you stop pushing data through, there might still be some data left in the tube, never came out the other end. But when you are stuffing data inside, it's like the data is arriving in New Relic and populating the aggregation window. When you stop stuffing data, data stops flowing and alerts stop working. If your proxy server goes down or something else technical goes wrong, the system stops moving when the data stops flowing. This method provides the best reliability, accuracy, and latency for time series signals whose data points arrive consistently and frequently. For the most part, this is the case for most infrastructure and application metrics. If your data is very sparse, however, Event Timer would be a better fit for you. Event Timer, which is an event-based streaming method, ultimately uses a timer based on processing time to determine when to finish the aggregation for a specific aggregation window. This timer starts when a data point is received and is reset by a subsequent data point which has a timestamp that maps to the same aggregation window. If the timer expires before being reset by another data point arriving, then the aggregation function runs and the resultant data point is set downstream for evaluation. If another data point arrives for the same window before expiration, the timer resets and the process restarts. To put this into a visualization, let's imagine you are driving a secret limo for a highly executive customer. Your job is to ensure the customer is picked up and any additional requests are met. You get to the pickup spot and are waiting for your customer to come out. Once they show up, however, they ask you to wait for another 5 minutes because their friend is coming. However, they mention leaving if they don't show up in 5 minutes. Let's say their friend shows up and asks for another 5 minutes because their friend is also coming. You wait for 5 minutes, but their friend doesn't show up, so now you leave. It's a weird example, but to put it into theory, you can sit at the pickup spot forever if the first client doesn't show up, and you can also sit there forever if friends keep showing up every 5 minutes. This streaming method is not concerned with the data flowing in, but rather focused on the timer set by you. This streaming method is for customers who don't know when the first data point will show up, or for those who know how frequent their data will show up in a certain time window. The last streaming method is Cadence, which is the name for the method we have used historically. In this method, the decisions regarding when an aggregation window is considered complete and ready for evaluation is determined solely by the server's clock time. What does that exactly mean? Well, let's imagine a final scenario. Imagine you are a pilot flying planes from San Francisco. You're given a time when the plane must depart. Your goal is to leave exactly at the given time, not a minute later, not a minute earlier. Whether all the passengers show up on time, some arrive late, or the whole plane is empty, you don't really care. At the given time of departure, you're going airborne and flying with or without any passengers. That's what cadence is like. You set a timer. If the data comes in or not, you don't care, as long as it stops at the exact time you set. Congratulations! Now you've learned what each aggregation method means and can choose the method that works best for your use case. For further tutorials in AIOps, visit our docs page under New Relic Applied Intelligence. Thank you and happy streaming.